So this is an E900 PC, a netbook, old netbook that I bought as the brain for my robot boat project. And since it was only 20 bucks on eBay, of course it isn't working. Turns out there's a very common failure mode in this particular model of machine, and it's the failure of a power MOSFET. I've already cracked this one, like lobsters. They're better opened before you start the cooking video. And you observe there very closely that 8-pin SOIC there. That's the culprit, and it's a very, very common failure on this. If you search around the internet on the part number of that MOSFET, most of the results you'll find are actually people talking about their EPCs that have stopped working, and they've opened them up, and that's been the part that's failed. So we're going to do a very quick and dirty repair here. I actually bought the equivalent, although not the exact right part, from Mauser. Just going to adjust this to make sure we're focused on the right area. And you can see I'm centering in there on the correct part, which is this one. We'll see how well we can do this without moving the machine. This is the quick and dirty way, like I said. If you don't have a hot air rework station, this is the quickest way of doing things. Temperature adjusted soldering iron, yes, but not strictly the right tool for the job. So what I do is I just melt together enough solder to cover a big blob on all pins on one side and again on the other side. In this particular case we have to be a little bit careful because there are a couple of small components right next to this chip, and I don't really want to pull them off because it would be an annoyance in the extreme to go finding replacements for them. Especially since all of my SOIC parts are packed up in a box somewhere from my move from New York. So now that we've got one side completely melted, we should be able to lift that side a little bit if we melt all of those pins at once. And we use the tweezers to just lift it a little bit off the PCB. You'll find that there's quite often some glue underneath the chip from the assembly process on a double-sided board. And that is in fact what's holding it down in this case. You'll also find that it's sometimes difficult to get the solder to stick to one or more of the pins, which is what's happened here, and that's why this end isn't melting happily. I've rocked it up a little bit, but you really need to get both sides melted at once if you possibly can. This is also not a very powerful soldering iron. It's, what is it? It's the Lona 951SX, I don't know what wattage it is, but it's not a very high wattage soldering iron. So this side is the one that's easier to melt because it's got thinner traces leading away from it. So there you can see it's already coming up. And the other side now, a little bit more. Barking is from an additional piece of laboratory equipment not illustrated in this video. And a little bit more there. A little bit more here. This is usually the point at which I realize that I'm working on the wrong chip, but luckily in this case that's not true. There's only one thing that's damaged on this motherboard, at least only one thing that's obviously damaged. So we rock up the other side a little bit. I usually use an X-Acto to do this, but I can't find mine, so I'm using tweezers, which will probably have to be thrown away afterwards because they've gotten quite bent in the process of doing this, but that's okay. There we go, that's the other side starting to come up there. And sooner or later you get to this point, which is where one side is up enough that you can bead the solder right away from all the pins, and hey presto, it's gone. Now we need to clean up the traces on the board. Again, it would be nice if I had a desoldering braid with me, but as I don't, I'm going to do this the quick and nasty way, which is just to run the iron quickly between the pads. Strongly don't recommend you do this unless you're working on something of no value or you've done it many times before, because this is a great way to rip traces up off the board, especially when you've got thick traces interleaved with very thin traces, which unluckily you happen to have here. Now, almost there. So these particular two traces right here are on either a power or a ground. They're very, very thick traces. In fact, it's just one single trace with two holes in a solder mask. And that is why I'm having so much trouble getting the solder away from there. So I'm going to add a little more, since I don't happen to have any loose flux around. Flux would be the ideal thing to use here. If you don't have desoldering braid, which I don't happen to have handy. And 7 out of 8 are good. It's just this last joint here that's being a bit of an annoyance. Now, don't try this at home, kids. Perfect. And we just get rid of those little drops of solder and we should be good. Magnification is a big help here, but again, it's not readily available to me tonight, so I'm going to live without it. Alright, that's about as clean as it's going to get. I'm just going to remove a couple of those little bits of solder that I blasted all over the place. The screen on this, by the way, does work, although it doesn't matter to me because the application which I'm going to be using it doesn't require a screen anyhow. And I'll probably be taking the screen off it, in fact. So if anybody wants a spare screen for an EPC 900, just drop me an email. Very much doubt that I'll ever find a use for it. Goodness knows I've got enough junk LCDs. Okay. Just being extra careful there because this is a power MOSFET. And double check with some more light. Again, high-tech lighting equipment here. I'm a big believer in making do with what I've got, so this is what I've got. Perfect. Now, let's get into our exciting package. These are the wrong parts. I will be very annoyed because it means that this one-take video won't actually contain the whole process. And much like gentlemen who work in the adult entertainment industry, I don't do any editing and I only do one take. Perfect. Alrighty, this is our replacement part right here. And if I can steady my hands after tonight's sake enough to pick it up properly, this is the correct orientation. This is not going to be the neatest job you ever saw, needless to say, but good enough for government work, especially good enough for this job, since this is really only a proof of concept anyway. And the whole reason I'm doing this is because I was too cheap to spend $100 on a completely working netbook rather than $20 on one that was sold as is. Gotta love eBay. So I tack it down by just melting the solder on one pin, and then this is the part that requires hand-eye coordination and probably shouldn't be done after an evening's drinking. Solder down each pin. Putting the new part on is much easier than getting the old part off. However, if you screw something up and you short together a couple of pins, that's the point at which you can typically start swearing. So in theory, that this machine is now working again. So if that was in fact the only failure here, I should be able to power it up now. Well, promising. I plugged in power, I see power LED. How about that? This machine is now fully functional. Well, at least as fully functional as it needs to be. So that is how you replace that power MOSFET, and I'm truly glad that that was in fact the only failure in this machine. I will see you next time.